site-to-site IPSec VPN. This video will focus on configuring, verifying, and troubleshooting site-to-site IPSec VPN tunnel between two SA5510 firewalls using command lines. Please note, there are a number of configuration changes on firewalls running on iOS 8.4 or newer and iOS older than 8.4, which means command lines will vary depending on the iOS. Pre-configuration checklist. Before I start to configuring, I will go through the pre-configuration checklist. For example, ensure what iOS version is running. Simply, it can be verified by issuing show version on the firewall. So my system image or my iOS image is 8.4. So just it is now it is being verified that I have this version of iOS on both firewalls on both sides. And next slide is the network topology for this lab. I have two firewalls, 5510. I have two sites, London and Paris. The cloud consists of two routers, and the routers are configured with OSPF routing protocol. On the inside network, I have switches and desktop and laptops. Here, to save time, Paris firewall is configured and ready. I have already configured with all the configuration for the IPSec VPN tunnel. The focus of this lab is on London firewall. Configuration steps. There are two phases, phase 1 and phase 2 steps, and there are 4 steps on this configuration. Step 1 in phase 1, enable IK. Step 2, create IK policy. Step 3, set the tunnel type. IK phase 2 or IPSec phase 2 is step 4, define IPSec policy. Step 5, access list and identity NAT rule. Step 6, define and apply crypto map. Step 7, verify, troubleshoot, and make sure traffic flows flawlessly. Next, let me start the configuration of London firewall. I will configure IP address, interface name, and security level. So interface Ethernet 0. Name if outside. By default, it is set to the outside interface set to 0. The security level is set to 0, and the IP address is 101.101.1.1 with 24 subnet mask and a shutdown. Okay, interface Ethernet 1, which is the inside interface name if inside. This as well, it's set to 100. The security level is set to 100. So IP address is 10.100.100.1 with the /24 subnet mask and do not shut down. So both interfaces are configured, and let me do root outside static root. So my default gateway is 101.101.101.2. So I just put the static root to the cloud. Let me save it. Okay, so ensure that there is connectivity to both the internal and the external network before we proceed to the next step. So I will check the connection between London outside interface to Paris outside interface. It should have connectivity, so I can verify this by pinging to so I can ping from London interface one outside interface to Paris outside interface 202.202.202.1. So there is connectivity between London and the Paris firewall, or between the two sites. So the next step is IPSec phase 1. IPSec phase 1 configuration starts by enabling IPSec on VPN tunnel interface or on the outside interface. So enable on the outside interface. So the next step is define the IPSec policy. IPSec policy defines how VPN tunnel is formed, authenticated, and protected on phase 1. I'm going to create only one policy on my lab and select the following parameters. These parameters need to agree on both ends of the tunnel. So this is the IPSec attributes. I just want to put it on a table. Authenticate method. I'll select the pre-shared keys. Encryption algorithm, AES, advanced encryption standard, hash, SHA, key exchange method. This is Diffie-Hellman. I will select Diffie-Hellman group 2, and IPSec security association lifetime, which is, this is optional, but I will set to 86,400 seconds, which is 24 hours or 1 day. Policy 10, authentication, pre-share, and encryption, yes, group, development group 2, and the lifetime 86,400 seconds. Okay, let me save it. Okay, the next step is to set up the tunnel group. Tunnel groups, also known as connection profile, which is defined site-to-site tunnel. I'm going to configure a tunnel group to tell the firewall a site-to-site VPN tunnel, and create a shared secret. The shared secret should be the same on both ends of the VPN tunnel. The tunnel group, which is this one, is the IP address of the peer firewall. Tunnel group type IPSec LAN to LAN. IPSec attributes, then I will set the pre-shared key, which is lab123. Save. So phase 1 configuration has now been completed. So I will proceed, or I will continue into IPSec phase 2 or IC phase 2. IPSec attributes, I put the attributes for the second phase or phase 2. I just put what encryption and authentication or hashing I will be using. So that's the configuration command line. So the firewall on phase 2, I will define transform set. The firewall needs to know how to protect the data. This is where transform set comes into play. It defines what hashing and the encryption algorithm to be used to protect the data. Crypto IPSec version 1 transform set. I will call my transform set ASP yes SHA. Encryption I will use AS, and hash I will use ASP SHA H mark. Okay, so the next step is, let me go to my slide. The next step is creating an access list. An access list and interesting traffic over the VPN tunnel. In order to differentiate the traffic that should be protected with IPSec encryption from the traffic that doesn't require protection. So first I would define the object group. objective group for the local for the inside network, and for the inside network on both sides, for London and Paris. Object group network. I'll call my object group local LAN, and the network object, this is the London inside network, and the inside IP address. Call again, this is for the Paris inside network. I'll call it remote LAN, and the network should be 20.200.200.0 with /24. I create both object groups for London and Paris inside network, and then I will create an access list. I will call my access list SA VPN extended permit IP object group, that's the source, local LAN object group, that is the destination, is remote LAN, which is the Paris inside network. Okay, that is complete. The next step is identity NAT rule. Identity NAT rule simply translates an address to the same address. So create NAT inside, outside, source, and static, local LAN, destination, and static, remote LAN, remote LAN. Okay, so now the configuration for phase 2 is also completed. The final step is, or the last step is to define the crypto map. After both phase 1 and phase 2 policies are configured and complete, crypto map should be defined so that policies can be applied to IPSec tunnel. Okay, let me start. Crypto map. Since I'm on London firewall, I will call my crypto map LON map to match address. This is the access list name, crypto map search. This is Defi-Hellman group 2. So this is the peer, which is 202.202.2 1. That's the Paris outside interface. The Paris firewall, the firewall, the outside interface for the Paris site. Then the last crypto map is to set the transform set. And my transform set is ISP AS. So once all the crypto map defined, I need to apply the crypto map into the outside interface. Crypto map. My map is map interface outside. Okay, so the configuration for both phases, phase 1 and phase 2, have now been completed. The final stage is just to verify and troubleshoot if there is any problem, but you can verify this. So first let me save it. So let me go to my first is, let me go to my topology back. So I will start to verify by pinging from my laptop here to this desktop in Paris. So if I ping successfully, then the tunnel is set up correctly. So IP config, let me verify my laptop. So it is, my IP address is 10.100.100.4. So I will ping 20.200.200.4, which is this computer. Yep. So I can see it is, I can ping from my laptop 10.100.100.4 to Paris site internal network 20.100.100.4. So the tunnel is configured correctly and it is accessible. So let me verify more. Show. I put a number of verifying command lines here. All this can check to verify, and if there is any problem you can do debug for phase 1 and phase 2 to identify what is the problem. In phase 1 you test it, then in phase 2 if phase 1 is correctly configured, then you can proceed if there is any problem in phase 2. So let me check first if crypto map ICamp SA details. So I can see here just the status, it says is active. So it is the phase 1 configuration here. You can verify it is up and corrected, configured. to check the phase 2, which is IPSec. Okay, so here we can check the packet encrypted, packet decrypted, which is says 3 and 3. If we go to our ping, send 4 packets, 1 dropped, sent 4, received 3, which is the 3. 1 is dropped during the negotiation. So according to here as well, there are 3 packets encrypted and the 3 packets are decrypted, which is shows that it is the tunnel is up and the data are encrypted. There is another configuration which you can verify. Use the VPN session summary. So it is site-to-site VPN. We have just one and it is active. So you can verify using this command as well. So there's a number of command lines to check if there is any problems or if you want to verify. So the objective of this lab is to show how IPSec is configured and verified, and also troubleshoot if there is any problem. Hope this is informative. I would say thank you very much for watching my training video, and please feel free to post your feedback, and also remember to subscribe and click like. Thank you very much.